All right, here we go into a problem that involves long division. That's right. When you've got an integrand where the powers of the polynomial in the numerator and the denominator are either equal or the numerator's degree, power, is 1 or more, then you should use long division. See what happens. So I'm going to use long division here. If this power were just to the first, I might use synthetic, but long division always works. So I've got this. I'm going to do what the problem tells me to do. You might say, how do you know to do this other than memorizing the circumstances? I look at that and say, what could I do? Well, I could divide, and that's one heck of a weird division symbol, but I could divide. That's what it's telling me to do. So I'll divide x squared plus 1 into 5x squared plus 6x plus 5, little long division work. When we're doing this, we're saying what times x squared gives me 5x squared? Well, that would just be 5. 5 times, we now multiply this, 5 times x squared is 5x squared. 5 times 1 is 5. And what I do is I subtract all of this from all of that, just like you do in normal long division. 5x squared minus 5x squared is 0. 6x minus, there's no 6x term, so it's minus 0, 6x. 5 minus 5 is, well, 0. So what that means is that's our remainder because we can't have an x squared go into 6x. Not a polynomial times x squared will give us 6x. So our answer is 5 plus 6x divided by x squared plus 1. Now why does that matter? That is equivalent to this. That's all we've done is divided. Like if I said give me 20 divided by $4, I'm really saying give me $5. It's just a different way of doing it. So here's the 20 divided by 4. Here's the actual divided out $5, so to speak. So now by rewriting and manipulating our integrand, we can now take the integral. Now I want you to look at this integral as basically two different integrands. You've got the integral of 5 dx plus the integral of, now that's 6 I don't like. I'm going to factor it out. 6x dx all over x squared plus 1. I've separated this into two different integrals because the integral of 5 dx, that's easy. That's 5x. So hold that thought. Don't forget that that's there. This is going to need some u substitution. If you get really good at the mental math, though, you might be able to say, okay, I see what the integral is right away, and that's fine. Eventually get there, but for now, let's use u sub. So I'll take this integral right here. So that's going to be, well, 6 times, let's let u equal to x squared plus 1. U is equal to x squared plus 1. Du is equal to 2x dx. And I know to let it equal u because you've got u prime over u. Nice. So du is 2x dx. I need to put in a 2 and divide by 2. So here's the division by 2. 2x dx is now du. Oh, very nice. All over x squared plus 1 is u. We have that right here. Now we've got 3 integral of 1 over u, du, if you want to write it that way. And that is just ln of the absolute value of u. So 3 times the ln of the absolute value of x squared plus 1. Okay. Now, remember, we have 5x. We have this antiderivative. We'll add the two antiderivatives together. 5x plus 3 ln of, now I'm going to put this in parentheses because, as I mentioned in a previous video, if you don't need the absolute value, a lot of teachers, some, don't want you to keep it there. It really doesn't matter, like if you're taking an A, B, or BC exam, if you have the absolute value there and they're unnecessary, but x squared plus 1 is always positive, so the absolute value is unnecessary. All right, that's it as far as long division goes. A great example. I'll see you in the next video. Peace.